So sum rule. Suppose the two tasks T1 and T2 are to be performed one after other. If T1 can be performed in m different ways and T2 can be performed in n different ways, so then the total number of ways of performing two tasks in m plus n different ways, that is called as the sum rule. Okay, so one task can be performed in m ways and T2, then other task can be performed n different ways. Then go for the sum rule, that is the m plus n different ways. Okay. See, for example, suppose a library has 12 books on mathematics, 10 books on physics, 16 books on computers, 11 books on electronics. Suppose a student wishes to choose one of these books for study, then the number of ways in which he can choose a book is 12 plus 10 plus 16 plus 11, that equal to 49. Okay, so in a library, so different books are available. In that way, a student will be choose one of these books of for study of the number of ways is total books has 12 plus 10 plus 16 plus 11, that equal to 49 ways he wants to study. Okay. And next one, product rule. Suppose the two tasks T1 and T2 are to be performed one after other. If that is T1 can be performed in m different ways and T2 can be performed in n different ways, then both of these tasks can be performed in m by n different ways. Okay, you go for the sum rule, that is m plus n different ways. Then go for the product rule, that is m by n, that is m into n different ways. Okay, that is called as the product rule. There are the two rules. The first one is sum rule and second one is product rule. In sum rules, it will be performed two tasks, that is it performed in the m different ways, n different ways, that is the m plus 1 different ways, totally the tasks will be performed. Then go for the product rule. T1 T2 are to be performed in one after other. If T1 can be performed in m different ways and T2 can be performed in n different ways, then both of these tasks can be performed in m by n different ways. Okay. See, for example, suppose a person has 3 shirts and 5 trousers, then he wants how many different ways of choosing a shirt and trouser, that is 3 into 15, sorry 3 into 5, that equal to 15 different ways of choosing a shirt and trousers. That is, if a person has 3 shirts, that is the first shirt 5 trousers, second shirt 5 trousers, third shirt 5 trousers. So totally 15 possible ways you have to choosing the shirt and a trouser. So likewise we have to do for the product rule, that equal to 3 into 5, that equal to 15 different ways of choosing a shirt and a trouser. Okay, that is called as the product rule. Next, see. A man can spend his evening in one of the following ways. See, he can do shopping, or he can go to cinema hall, or he can go to restaurant. If there are 6 shopping complexes, 8 cinema halls and 9 restaurants, then how many different ways he can spend his evening? That is, by using of sum rule, he can spend his evening 6 plus, like 6 shopping complexes plus 8 cinema halls plus 9 restaurants, then that equal to 23 different ways he can spend his evening in that particular ways. Okay, so totally 23 different ways he can spend his evening. Okay, using of the sum rule. See, if two distinguishable dice are rolled, then how many ways can we get a sum of 4 or of 8, and how many ways we can get any sum? Okay, so there is 4. So there are 3 ways to get a sum of 4, that equal to 2 2, 3 1, 1 3. So these are the 3 possibilities we can roll a dice. Okay, so everybody has know the dice. Okay, so whenever we have to roll the dice, we can get a sum of 4. It will be 3 different possible ways, that is 1 comma 3, 2 comma 2, 3 comma 1. Okay, And likewise, there are 5 ways to get sum of 8, that is 2 6, 6 2, 3 5, 5 3, 4 4. So when using the sum of 8, whenever we have to roll the dice, we will get 5 ways. So next, the number of ways to get a sum of 4 or 8 that equal to 3 plus 5 that equal to 8. See, 3 ways to get 4 and 5 ways to get sum that equal to 3 plus 5 that equal to 8 ways to possible we can get a sum of 4 or of 8. Okay. Next, the number of ways we get an even sum that equal to 2 or 4 or 6 or 8 or 10 or 12. Okay, it may be possible only 12. So in that way we go for the even sum is 2, 4, 6, 8, 10, 12. Okay, so go for 2, only single possible. Go for 4, 3 possible. Go for 6, 5 possible. Go for 8 also 5 possible. Go for 10, 3 possible. Go for 12, only 1 possible. That equal to totally 1 plus 3 plus 5 plus 5 plus 3 plus 1 that equal to 18 ways. So whenever we have to roll a dice, then we get an even sum is 18 ways. So even sum means if the possibles are maybe 2, maybe 4, maybe 6, maybe 8, maybe 10, maybe 12. So when you have to roll the sum of 2 equal to 1 possibility, go for 4, 3 possibility, go for 6, 5 possibilities, and go for 8, 5 possibilities, and go for 10, 3 possibilities, and go for 12 is a 1 possibility. Okay, that equal to 18 ways are possible whenever we can roll a even sum. Next, if two distinguishable dice are rolled, in how many ways can they fall? See, the first die can fall in 6 ways and the second also will 6. That is, by product rule, the number of possible outcomes are 6 into 6 that equal to 36 possible outcomes are whenever we have to choose two distinguishables are rolled. Okay, see, the first dice can be fall in 6 ways and the second can fall in 6 ways. So by the using of product rule, the number of possible outcomes that equal to 6 into 6 that equal to 36. Similarly, if 5 distinguishable dice are rolled, how many possible outcomes are there that equal to 6 power 5? That is 6 into 6 into 6 into 6 into 6 that equal to 6 power 5 possible ways whenever we have to roll a 5 distinguishable dice are rolled. Okay. So 2 HSE 36, 5 HSE 6 power 5. Okay. Next. A man wants to spend his evening in the following way. First, he would like to do some shopping, then like to go to cinema hall, then finally would like to go to restaurant. So if there are 6 shopping complexes, 8 cinema halls and 9 restaurants, then how many different ways he can spend his evening? That is, so he go to shopping and then also he go to cinema and finally he go to restaurants. So 3 are because choosing that one. So in that way, that is the shopping complex are 6, cinema halls are 8, restaurants are 9, that equal to 6 into 8 into 9 that equal to 432 ways he can spend his evening. Okay. So in the చూడండి. A man, then he can do shopping or he can do cinema hall or he can do restaurant. And only one thing, maybe shopping or maybe cinema hall or maybe restaurant. So in that way we can using sum rule, that is 6 plus 8 plus 9. But on the product rule, he go to all the things, go to shopping, then go to cinema hall, then go to restaurant. Okay. In that way, that equal to 6 into 8 into 9, that equal to 432 ways possible to do. He can spend his evening. Okay. Next, how many how many 3-digit numbers can be formed using the digits 1, 3, 4, 5, 6, 8 and 9? The next one, how many 3-digit numbers can be formed if no digit can be repeated? Okay, see how many 3-digit number can be formed using the digits that may be repeated. Second one, that not be repeated. See here, each of the 3 digits can be filled in 7 ways. So total any possibilities ఉన్నాయి 1 2 3 4 5 6 7 possibilities ఉన్నాయి. 3-digit number తీసుకోవాలి. It may be like 1 into 1 2 3 కావచ్చు, లేదా 1 3 4 or 1 3 5 or 1 5 6 1 5, whatever you are using the 3 digits. But what we say here, it may be repeated. If it is possible to repeat it, then how many ways it will be arranged? Okay, see here. Here, each of the 3 digits can be filled in 7 ways. By product rule, the required number of 3-digit numbers that can be formed equal to 7 into 7, that equal to 340 possible ways to 3-digit number can be formed. Okay, that is, so why we are choosing 777? Because of it may be repeated. That may be 77, like totally 7 digits. So 777, 77. Okay. Next, if the repetitions are not allowed, that is the required number of 3-digit numbers that can be formed 7 into 6 into 5. That is total numbers are 7. If one number is assigned, if there is next number is 6, if this number is assigned, next number is 5. So totally 210 possible ways. Okay. చూడమ్మా రిపీట్ అవుతుంది అని చెప్తున్నాను కాబట్టి 777 అంటే 1 యూస్ చేసాము, మళ్ళీ ఈ 7లో యూస్ చేసుకోవచ్చు, లేదా మళ్ళీ ఈ 7లోనే అంటే 1 యూస్ చేయొచ్చు, మళ్ళీ 1 యూస్ చేయొచ్చు. కాబట్టి ఏం చేస్తామంటే ఇట్ మే బి రిపీటెడ్ మీన్స్ టోటలీ నెంబర్ 7, then 77. The repetitions are not allowed because first one is assigned, remaining are only 6. Second one is assigned, remaining are 5. Third one is assigned, remaining are 4. So likewise, whenever we have two repetitions are not allowed, then it will be formed as 7 into 6 into 5, that equal to 210 possible ways we can form the 3-digit number if digit cannot be repeated. If it is repeated, 777 equal to 343. If it is not repeated, that is equal to 7 into 6 into 5, that equal to 210. Here we cannot choose these numbers. We have to do the total number, that is the 7. Okay. Next. See, in how many different license plates are there that involve 1, 2 or 3 letters followed by the 4 digits? See here, we can assign one of the license plate that involve 1, 2, 3 letters, the followed by the 4 digits. 4 digits ni follow avali cheptunna. So letters are only 26, digits are 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, see, by the product rule, the number of plates with one letter is followed by 4 digits, that is equal to 26 into 10 power 4. 2 letters are followed by, that is equal to 26 square into 10 power 4. 3 letters are followed by 4 digits, that is equal to 26 power 3 into 10 power 4. Okay. So, in how many different license plates are there that involve 1, 2 or 3 letters may be followed by 4 digits. So letters are totally 26 letters are there and digits are 10. In that way, the number of plates, there is one letter is followed by, that equal to 1 letter means 26. It followed by the digits that equal to 10 power 4. The number of plates, 2 letters, that equal 26 square into 10 power 4. The number of plates, if 3 letters are followed by 4 digits, that equal to 26 cube into 10 power 4. Since these 3 cases are mutually exclusive by some rule, we have therefore the required number of license plates equal to 26 into 10 power 4 plus 26 square into 10 power 4 plus 26 cube into 10 power 4, totally 26 plus 26 square plus 26 cube into 10 power 4. This is the answer. Okay. So multiply చేయాల్సిన అవసరం లేదండి, జస్ట్ ఇలా అసైన్ చేసినా సరిపోతుంది. ఓకే. సో లెటర్స్ ఆర్, టోటల్ లెటర్స్ ఆర్ 26, డిజిట్స్ ఆర్ 10, 2 లెటర్స్ కాబట్టి 26 స్క్వేర్, 3 కాబట్టి 26 క్యూబ్. ఓకే. నెక్స్ట్ permutations and combinations. See, permutations. A permutation of n object taken small or at a time, that is called as an or permutations of an object. See, a permutation of n objects taken small or at a time, also called an or permutation of n objects, is an ordered selection or arrangement of small or of the objects. Okay, so how it will take n objects taken or at a time. See, p of n comma r, there is a permutation of n comma r that equal to the number of permutation of n objects taken or at a time without repetitions. The number of permutations of n objects taken small or at a time without any repetition. And p of n comma 1 equal to n, p of n comma t equal to n into n minus 1, p of n comma 3 equal to n into n minus 1, n minus 2, and so on. P of n comma r equal to n into n minus 1 into n minus 2, and so on. N minus of r minus 1 is equal to n factorial by n minus r factorial. These are the formulas. Then p of n comma n is equal to n factorial, that is there are n factorial permutation of n objects. Okay. Next one. No. So there are n minus 1 factorial permutations of n distinct objects around a circle, and u of n comma that equal to the number of r permutations of n objects with unlimited repetition that equal to n. Next one, the number of permutations of n objects of which n1 are alike, n2 and so on n are that equal to n factorial by n1 factorial into n2 factorial into and so on n r factorial. Okay, the number of permutations of n objects which n1, n2 and so on n r, that is n factorial by n1 factorial, n2 factorial and so on n r factorial. Okay, next one, the number of ways to arrange n different parallels in necklace is n minus 1 factorial by 2. Okay, these are the rules. Next one. The number of ordered partitions of set S of type Q1, Q2 and so on Qk, where modulus equal to n is, that is P of n semicolon P1, Q1, Q2 and so on Qt equal to n factorial by Q1 factorial, Q2 factorial and so on Qt factorial. Okay, this is the order number of ordered partitions, that is n factorial by q1 factorial, q2 factorial and so on qt factorial. Okay, next one. See, what has been permutation? That means number of ways, that is number of ways a group of things can be arranged, that is number of ways a group of things can be arranged. Okay, it is called as a permutation, that is number of ways a group of things can be arranged. For example, how many ways the word ABC can be arranged means ABC, ACB, BAC, BCA, CAB, CBA. So there are 6 ways we can arrange the word ABC. It is very easy to arrange 2 words, 3 words or 4 words, but cannot arrange if there are more words of 10 words. So we can go for the permutations. So simply 2-3 words, this is not a problem. But whenever you go for the more than 10 words, we can use the permutation, that is the formula of permutation of P is P of n comma r that equal to n factorial by n minus r factorial. It is n factorial by n minus r factorial. We can using the number of more than number of words, then we go for the permutation, that is the number of ways a group of things can be arranged, that equal to n factorial by n minus r factorial. See, next one. Find the number of two-digit number that can be formed by using the digits 2, 3, 5, 6, 9. That is, if there is no repeated digits, that equal to C. Here given the 5 digits, we can have to form of two-digit number. So 5 digits are 2, 3, 5, 6, 9. We can form of the two-digit number. Therefore, the number of two-digit numbers are n factorial by n minus r factorial. N means 5 digits, that is 5 factorial by 5 minus 2 factorial, that equal to 20. That is 5 factorial by 3 factorial, that equal to 20. Okay, now so find the number of two-digit numbers that can be formed by using the digits that equal to 2, 3, 5, 6, 9. There is no repetition. So కాబట్టి ఏం చెప్తాము? So totally 5 that equal to n equal to 5 and r equal to 2 that equal to n factorial by n minus r factorial, that equal to p of 5 comma 2 equal to 5 factorial by 5 minus 2 factorial, that equal to 20, or 5 factorial by 3 factorial. So ఇలా రాసిన మార్క్స్ ఇస్తాను. So 5 factorial by 3 factorial or 20, whatever. Next. In how many different ways can you place 5 bits in a necklace? That is, if a necklace means a circle, then we have n minus 1 factorial, that n equal to 5, that equal to 5 minus 1 factorial, that equal to 4 factorial, that equal to 24 ways we can arrange the bits in the necklace place, that is the round circle. Next. See, find the number of distinct words that can be formed by scrambling the letters in the words, that is Miss, M-I-S-S-I, S-S-I-P-P-A, that equal to n factorial by P1 factorial, P2 factorial, P2 factorial. So already we have learned fifth one. This one. The number of ordered partition a set of S of type Q1, Q2, Qk, where S is n, that is n factorial by Q1 factorial, Q2 factorial, and so on Q2 factorial. This formula we can use on here. See. MISS, there is total number of letters, totally 11 letters are available, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 factorial by n number of repeated letters, that is m equal to only one time, 1 factorial, S is 1, 2, 3, 4, 4 factorial, P 2 factorial, I 1, 2, 3, 4, 4 factorial, equal to 11 factorial by 4 factorial, 4 factorial, 2 factorial, 1 factorial. Since I equal to 4, S equal to 4, P equal to 2, then M equal to 1. So that is the number of distinct words that can be formed by scrambling the letters in the words, that is total number of letters factorial by number of repeated letters, that equal to 11 factorial by the given word, how many times the particular word will be repeated. Letters will be repeated, that is M is one time, S4, I4, P2, that equal to 11 factorial by 4 factorial, 4 factorial, 2 factorial, and 2 factorial. Next, go for the reference, that equal to totally 9 letters. Okay, that is 9 letters, that is 9 factorial by R equal to 2 times 2 factorial, E 1, 2, 3, 4 factorial, F is 1 factorial, E is 1 factorial, C is 1 factorial, that equal to 9 factorial by 4 factorial, 2 factorial, 1 factorial, 1 factorial, 1 factorial. Okay. The condition is total number of letters factorial by number of repeated letters factorial. That is the distinct words that can be formed by the letters. Next one. See, the formula for non-repeated letters is no number of letters factorial. If repeated, like non-repeated, number of letters are factorial equal to shirt, 5 letters, 5 factorial, pen, 3 letters, 3 factorial, fridge, 6 letters, 6 factorial, fan, 4 letters, 4 factorial. That is equal to 120, 3 factorial is 2 into 3, 6, 6 factorial is 720, 4 factorial 1 into 3 into 4, 24. Okay. There is the condition, that is the number of letters factorial. Next, combinations. Okay, so combinations we will see on the next class. Okay. Thank you.